Hey guys, can you hear me? Okay. So my name is Krzysztof Zabłocki and I work with New York Times. And today I'm going to talk to you about why you should stop recompiling. Just to give you more background about me, I also freelance as a contractor to help teams grow teams and establish good practices for new apps and existing architecture. And this is important because I focus very much how to improve efficiency of people in the team and the developer tools around building the product. So let's think about the day in programmer life. So you get a feature request, you have to figure out a way to approach the problem, then you write some code to do that idea that you just came up with, you compile the project, you deploy it, you go to the specific screen that the feature is shown on, and then you hope to see the expected results. So this is a very idealistic description of what happens when we work. It's more like this. So you think about it, you code it, you compile it, you deploy, and then you wonder why the hell it doesn't work or doesn't compile. So we go around. So this is a very repeated pattern. And if you look at this, there's a lot of time that we spend between the compiling, deploying, and debugging, which is not something that we want to do. We would rather focus on thinking about those ideas and seeing them happen as soon as possible, because the cycle makes us feel good when we actually see the results working. And then we also sometimes wonder why it works in the first place, looking at the code. So today we are talking about how to stop recompiling, and as part of that, how to become more connected with the work that we are doing every day. And a lot of people might ask, whether isn't recompiling the natural process of our work? Is this something that we always have to do? And it might be natural, but it's not always necessary. And there are a lot of languages that we don't need to do it, and there are ways to do it in Objective-C and Swift, which I'm going to talk about. But first off, why should we care about this? Why should we try to avoid recompiling the project? And I'm going to talk about that and how is it going to help your work. Just to give you an idea why you should listen is this saved me tens of thousands of dollars, because more and more companies go into value-based pricing. You don't need to work 8 hours. You could work less as long as you deliver the results that they expect you to. So you should really think about this whole talk as a way to save time, be more engaged with your work. So let's look at the reasons why. So the first one is compiling is the #1 excuse for slacking off and procrastination. And I don't have anything against, playing with friends or spending time discussing with other developers. But the problem is watching the recompile spinner is not a proper break. It's not really a break from your work. It's actually very annoying, especially if you have long compile times. I would rather leave work earlier. And let's look at the example. So I have this app, Foldify, which is an Apple Essential app. It has over 1,000 graphics assets. It only has 15,000 lines of code in the app itself. It has a couple more times in the dependencies. But the bigger the project, the bigger the compile time. Ben talked about 7 minutes for the clean build, which is crazy. Crazy. And apps like that and Facebook are a great example when the cycle for compiling, deploying, debugging is extremely hard. And you have to also navigate to specific screens very often. So there's a lot of time that you spend actually interacting with the app before you get to the feature that you're interested in. So with Foldify, it takes me 25 seconds per change to get to the specific screen. And this is not a lot. In Swift, it's actually way worse, as seen just now. And how much worse? I actually just ran the numbers. And I would say, let me just show you something. So if it was like 2 minutes per the iteration cycle, that's crazy, right? If you do 100 iterations, you spend 3 hours recompiling. If you do 300, that's 10 hours. And let's get back to the talk. So the thing is, what I usually do is I usually get to between 300 and 500 iterations. It's completely impossible if you take 2 minutes for the deploy cycle. I don't have enough hours in the day to just spend compiling it. That wouldn't be enough. So we need to look at different ways of optimizing this. And a lot of times we only work on a very small subset of the application. So many times we are just tweaking stuff, we are changing the UX or changing the implementation. So when I am changing the colors or adjusting the designs, it should not be required of me to go and recompile the whole project, navigate to the specific screen. If I want to work, like for example, I'm working on a visual app or UX, and I want to tweak the value to see a bit different model, I can just do it and see the results immediately. And this is all native Objective-C. It works the same with Swift. So if you only need to change small bits, why do you need to recompile everything? So a lot of time spent there, and most of the time it's the UX that we work on. And remember, like the value-based pricing is something that as freelancers we tend to look for, because it means that we are tasked with specific features to implement, not necessarily sitting 8 hours in the office. So if you can save 2 hours every day, that means that you can either leave work earlier and spend time with your family, or you can earn more money. Depends on what your goals are. So it's very important. But even more important than that is the fact that every time that we have to wait for the spinner and see it's just compiling, we are sitting there, and that breaks the focus. One of the main themes of being a programmer and what you learn about productivity is we get into this focus zone when we have like a good flow, and it's very easy for us to keep everything in memory and iterate on the algorithms that we work on. But the thing is, when you have those long breaks, if you have to wait 2 minutes between your code change and seeing the results, that breaks that immersion that you have with your source. So when we get the immediate feedback, it allows us to experiment more. If you don't have to wait between builds, between changes in your code, you will do more of them. If you are tweaking designs or if you are experimenting with different algorithms, you naturally will change it more and get a better results in the end. Whereas when you have to wait for the spinner, what you end up is with a compromise. You end up with a compromise. So it's good enough. I'm going to finish here because I'm running out of time. This is taking too long. When we don't have to compromise, we end up with a much better solutions. And I feel like this is a huge benefit. There is this talk by Brett Victor on inventing on principle, and he goes even further with the developer tools.
Is where he's going to be. This is his future. And when I change the code, I change its future. So I can find exactly the value I need, so that when I hit play, he slips right in there.
This is pretty amazing things that we could do when we get that connection with our work. So you type you make the change in the code, and you immediately see the result. And Apple knows that. Apple realized that quite a few years ago when they introduced Swift. And with Swift, they gave us Swift Playgrounds. And they are a very good tool for algorithms. It's very useful. You get every line of code is instrumented, but there are some problems with it. For example, it's not very useful for most applications. I go to a lot of conferences and I ask developers, are they using Swift Playgrounds in their production work? Are they using it for day-to-day development? And a lot of people say no. And there are a couple of reasons. First of all, it's not a full iOS environment. It's not using the simulator as a whole. So there are things that don't work as expected. For example, like if you try to do perspective transform, doesn't work. There is a switch you can press to run the code in the simulator, but it ends up with a lot of issues, like very weird behavior. So it's not ideal. And because of that, some stuff that would work in your app doesn't work in the playground, which makes it a massive con for actually learning the APIs. They recently added support for user interactions, but when they released it initially, there was no support for that, so you couldn't use it for UX or UI prototyping. And one of the biggest issues, I feel, is how hard it is to include your real app code in playgrounds. Like, there are two ways to do it. You either create a framework or you copy the code. Both of those are very painful to do because if you want to work on UX, you would have to include pretty much the whole app. So what, create a framework from the whole app? It doesn't feel very good. And this is very problematic. The other thing is it's very slow. Because of the way it works, the instrumentation requires that each line of code has extra, when they compile, they actually generate way more code, so you can see the results and number of times the code was called and the result inline. The thing is, that's not necessary for a lot of work that we do. That's useful for algorithms. When you are trying to write quicksort, that might be useful. When you are trying to write a new UI animation or stuff like that, you don't really care. What you care is specific points in time where you actually get, okay, I want to see how this view looks after setting all those properties, not every single line of code. And they only work in XCode. So if you want to use AppCode or if you want to use other IDEs or other tools, it's problematic. And they often crash. We no longer get this crash. Now, we still crash, but we just have this status bar information, so they hide the fact that it's completely broken. And so the question is, are we supposed to wait for Apple to fix those issues? They are working heavily. They hire a lot of tools developers recently, which is great. But there are still radars that were open a couple of years back that are still not fixed or not replied to. So it would be much nicer to have a community contribution to those kind of problems. And what if you still write Objective-C? Or if you have a project that has both code bases, so you have Swift and Objective-C. Maybe you can copy some code into the Swift playground, but with when you work with the legacy code, you can no longer get those benefits. So it might be nice to write in Swift, but then it's very bad to write in Objective-C. So you have two different worlds to work with. And I would rather have a very nice and consistent experience between the languages. So what are the alternatives that we could use to achieve similar effects or even better ones? So do a lot of you know how Objective-C is built? It's a layer on top of C. The way it works, the way Runtime works, it's all because of that we have like it generating a lot of code on top of C. There are reflection system built into the language, and that allows us to do a lot of amazing runtime features. It's risky, but it has a lot of power. So for example, when you swizzle methods, you can change the implementation of existing classes. So you could change how view.appear works with standard UI view controller, which gives us some options. And the best option for us is code injection, which is a technique that leverages the power of runtime. The way it works, it's when you have running application, you can in iOS, you can compile bundles of code, so not just assets, but also code, and you can load them dynamically on running applications. And because swizzling allows us to change the implementation, we can compile the bundle, load it in real app, and then swizzle all the functions. And that way we can get a new behavior into existing application without having to recompile everything. And this also allows us to recompile just a single file. And there is a tool, there are actually two tools for it, but I'm only featuring one now because the other one doesn't support Swift, and we want to have the same experience. So there is an XCode Injection plugin, and you can still run plugins on Xcode 8, you just have to unsign the Xcode, which is not a big issue, and it doesn't prevent you from having a signed version for publishing to App Store. So this supports both the device injection and the simulator. So you can even inject on a running iPad, which is very convenient. But code injection by itself has some issues. Like I showed you in the Brad Victor example, he built a lot of tools, extra tools for you to work with. Instead of just having to type code, you could adjust sliders, you could change the time in the app. So there's more things that we can do to be more connected with our work and our tools. And when we want to tweak values, changing code and changing the number is not very convenient. It's more natural to just drag a slider or pick an image. That's way more user experience, like user-driven experience. So for example, So I actually created a tool soon after Apple released their playground, and I originally released this for Objective-C because people were saying it's impossible to have those kind of features without Swift, and that's why Apple only did it for Swift. It's actually not true. I built the prototype in 3 hours. I got the first release in under 12 hours, and it has some benefits. First of all, it's built on top of Code Injection, so it's benefiting from the community of those tools. I didn't create them. They did a lot of work there, other smarter people than I am. And it works with Swift and Objective-C. It has a DSL for tweaking values, so you don't have to change just the code. It's fully interactive, full iOS environment. It actually runs in your simulator or device, and you can deploy it. So not only do you can prototype it, but you can actually send it on hockey to your product team or the testers, which is very convenient when you work with teams, which I'm going to mention soon. And it's a lot faster because it doesn't have to do instrumentation on each level. You actually have a very convenient DSL that you can use to see the results that you are interested in. So, for example, when you want to change some variables, you can just use a DSL in both Swift and Objective-C for adjusting values. And what it does is when I create those adjusters for like the position of the camera here, you can see that I just add a couple of lines of code and then I connect it with the animation block. Animation block basically just synchronizes with the display rate. So we get like nice performance. And what happens, it's adding those controls, sliders with the values that you expected, which is very convenient. And you can do that for values, you can do that for images, you can even animate values. So I can change from adjusting to animating, and it automatically will animate it for me, given the range, which is very convenient. And when you go back from animating to adjusting, it remembers the previous state. So you can keep tweaking it, and if you already had a property, it's going to remember the last value that you set for it. And you can imagine how much faster this is, because it's a basically DSL that creates extra variables that are controllable by your application without having to do any special work, really, which is very, very nice. The other thing is, do we prefer to work in Xcode, Vim, Sublime, Appcode? The problem with Swift Playgrounds, one of the issues is, even though it's running in Xcode, it doesn't actually have the source completion. Like, it doesn't have the same source tools that your Swift files have. If you right-click on a playground, you can see that there are not many options there. You cannot refactor code. Even though like the Xcode refactoring tools are crap, I would expect at least to get the same level in the playgrounds, which is not what happens. So it would be nice to use different tools. If you want, you can use Vim, which I'm doing here. I'm not very good at Vim. I don't even have syntax highlighting. That's why I use Appcode, which I highly recommend. If you didn't use Appcode before, it's much better. But the thing here is, because the way it works, it's running a daemon and observing your file changes, it doesn't matter how you edit the files, whether it's edited in one editor or the other. The only thing that matters is what's the content of your implementation, what are the files that you are modifying. So if I go to Sublime, I will get basically the same results. So here I have syntax highlighting, I can change some values, and it will gonna reflect it. I didn't have to do anything in between, I didn't have to restart the app or anything like that, which is much more convenient. And the speed of this thing is so much better. And because of all the features, you basically have all the features. All the third-party libraries that you use in your real app can be used with this. The way it works, you actually just install the pod, and that's all. You just install the pod, you install the plugin, and you can work with it. So every third-party tool, code can be transferred between the playground and the actual implementation without having to do any changes. You can just drop the DSL calls, which are very simple. And because of the way the integration works, working with real app and real view controllers and views is extremely simple because it doesn't require you to copy code. It doesn't require you to do any of those things. It's fully interactive. So it was fully interactive way before Apple did, and I'm going to stand by the point that they Sherlocked my idea, which is great. Let them Sherlock it. I want Apple have people that are actually paid to work on these tools, so it's better for us as a community when they get inspired by the things that we open source. So everything works as expected in normal app. Any code that you write here can be put into your project and it will work. It's actually a part of your project already, so it's awesome. And it even works with Interface Builder. It's not going to be as fast here as Interface Builder because Interface Builder previews are actually triggered before the save of the file, and I can only listen for the file changes. But it's more accurate. So when I just create content, right now it looks the same. But the moment I start customizing attributes, like using, for example, the corner radius, you can see the difference that, like in Interface Builder, it's not expressed the same way. You could mark every UI view with IB designable, but I dare you to do that because it's not a very good experience. So it might be not as fast here, but it's more accurate. And it's fully deployable to device. So I used to work at Mashable in New York, and we were trying to figure out good user experience for one of the UI elements in our app. So what I did is I created this playground that I could just tweak the values, change the images, and I actually sent it to everyone on my team. And everyone could tweak the values, and you see there's a button there looking good. And if you press that, what happened, it would pop up the email controller with all the values written then. So everyone in the team could send me the values that they felt were good enough, were the ones that we were supposed to work with. So you just build it for production, you just send it, and it's like there is no customization here. You don't have to do anything special. Normal builds, part of your app, very useful. And this is something that really needs a demo, so I'm just going to show you. Let me just change the mirroring. And hopefully that's going to work because demos are never easy to do. So I'm actually going to attend something that I don't think has ever been done before. I have Git repository, and I'm going to run the app. And I'm just going to change the Git commit without having to recompile the project. So first of all, let's see what we have at the start. So 1 sec. So we have this view, which is not very visible because it takes very little space. So what I'm going to do is I have this commit here that adds zoom capability, which is very simple code to do. And now I can zoom in so you can see more clearly. Let me just keep this in front. So I can zoom in so we can interact with this. So when I press this button, nothing happens. When I press this, nothing happens. And then the way I added the zooming is, so I basically, here, I added this variable, adjuster, zoom, and then I just assign it to the view itself. So I can just zoom in so you can see clearly. So when I open the next Git commit, it's actually fixing the size that fits, because as you can see, there's quite a lot of space here. So I'm just going to switch the Git to this commit, and now it's fixed. It's proper layout, and it just added the size to fit method. But let's go further. So this is actually from a tutorial that I wrote for my blog about details of animations that make a big difference for your product. So the small details matter. So what I would like to do next is I would like to animate this view here so it actually collapses in 3D when I press this button. So I can just change to that. It's actually very simple to do. So this is actually real app. So I have this view, remember view, and what I just did is I added this part of code here. So just fill the function with some simple transform. And now when I press this button, this happens. It's pretty fast, so maybe we can slow it down a bit. So now I'm going to add another slider that allows me to slow down that animation. So now I can do this. But let's go further. Like I would like to have that when I press this button and there is some content, I animate the button text, which is something a lot of people don't know you can do. So let's switch to that. And what I added here is I added this function animate button. And that basically using the transition, the push transition. So look what happens here. I type something, I press, and this is just UI button. This is not a custom subclass. So I can just add functionality like that without having to do any recompilation. And right now, I just changed git commits. I did it 6 times. You can see here the counter. That's how many times you actually change the code that would require you to recompile the project and redeploy it. So 6 is nothing. When I work on this, normally, I get over 300 a day, easily. So just to show you that this should also work in Objective-C, I'm going to open Objective-C project here. I hope it works. Because a lot of these things you could do with Swift Playgrounds, but none of this, none of Objective-C you could. So here I have a different project. I have a different example written in full Objective-C, and let's say I just uncomment this code, and I have to run it once in Objective-C. Okay, so now, sorry, wrong shortcut. So run it once. Enable the recompilation. So here, inject source. And now, I just comment out code, and the implementation changes. So I go to this stuff, and I can interact with this. There's basically just some simple code that I wrote. And for example, like this is introspection, so it allows me to basically like instrumentation in Swift Playgrounds, except I control it. So if I comment out this sample playground, if I comment this code, and I save the file, this happens. So it adjusts all the instrumentation that I care about. This is very useful for working with different APIs. So for example, here, this is a Bezier path with shape layer. This is way more convenient to adjust it than doing it, because like some of the arguments, for example, the pattern, are much harder to do on your own. So here I can just adjust the code and see the result immediately, way faster than Swift Playground, by the way. So this allows me to not only learn my APIs, but also save a lot of time when I'm contracting and basically generate bigger return of investment. So imagine like working on your real app and working on a custom view or custom user interaction. How many times did you have to tweak the animation values? How many times did you have to tweak some design stuff? And now multiply that by the time it takes to deploy. How much time are you wasting? This is a lot of time. Honestly, this has saved me so much money. If just for that, I would recommend doing it because it just allows you to save a lot of money or time, whatever you care more about. Okay. So yeah, it's available for free on GitHub under XCode Playgrounds. And the thing here is, you don't actually have to use my tool. It's just an architecture built on top of Code Injection. You can use Code Injection directly, but when you do, then you have to make sure that every time you inject new code, you clean up the state. So it always starts from a clean slide, which is might not be that easy. So the playgrounds, the way the playgrounds work, they actually destroy and recreate all the content that you put into the playground, which allows you to basically create your instance of your view, work on it, and then you can expect the same behavior from your app as you run the original compilation versus like the 100th one. So download it, play with it, it's very useful. And for the future, if Apple is watching, I think what we need to do is we need to simplify the integration with our app code. So when working with Swift Playgrounds, I would like to be able to add them to existing projects and for them to have access to everything in the project itself automatically without having us to do any manual labor, because it really should not be necessary. Obviously, we need to improve stability because they are still a little cranky. And we would like to get the same tools because hopefully one day we will actually have refactoring tools in XCode. Okay, thank you.
Thank you, Krzysztof. Any questions? Okay, hi, my name is Daliso. What I was quite curious was the performance overhead compared to your Swift playgrounds. And like, for example, I could see that you've got quite a powerful machine there. For us who don't necessarily have like the best machines, how does it necessarily compare to what Apple's currently providing?
Okay, so I would say at least 10 times faster. That's like at least the level of speed. It's a different magnitude, because the problem with the way Swift playgrounds are working, they're actually like, so there are things you cannot do with this. Like there will be issues that you run into, but not much with when interacting with UIKit frameworks, all the frameworks that Apple gave us because they are Objective-C. So for those things, code injection works very, very well. I very rarely run into issues. What they do with Swift playgrounds, they actually recompile and rerun the whole thing, right? So you have a way more work to do other than just the instrumentation. So they also inject instrumentation code into your source code. So that's probably why mine is much faster, because it can only, like you can only recompile a single file. So even if you have 10,000 files in your project, you're actually just injecting one. So the bigger the project, the bigger the difference, right? And with huge projects like Facebook or Yelp, this could save you like hours every day. So it's not a matter of, oh, I'm going to be 10 minutes faster. It's a matter of, oh, I'm going to leave work at 3 p.m. instead of like 6. So yeah, it's a different magnitude. So whatever device you're using, you will see like significant differences.
Thanks for a great talk. I'm wondering, are you using this playground stuff in a real project? And how do you manage those? Like you have multiple playgrounds. How do you manage this by making each target or?
Okay, so the way it works is actually kind of interesting, because I like runtime. I know a lot about Objective-C runtime because I did a lot of tools before, like a couple of years back, when like I started before the public SDK was actually a thing. So I started with the toolchain. And the way it works, you can have hundreds of playgrounds in your app, and the way you select the active one, you just add a protocol attribution called KZP active playground. And the runtime finds out what class implements that protocol. That protocol is empty. It's just like a comment, basically. And it runs that. So even with 100 playgrounds, you just select the one that you want to activate, and that's it.
Oh, great. Thank you.
Hello. Yeah, so when we work on iOS, a lot of time we need to, let's say, connect to the server to download the data and display it on the phone. So can your playground, let's say, the user click on the button and then the app need to connect to the server to get the image to display on the phone?
Yeah. So the question, if I understand, is how do you effectively work with some data that you need to fetch asynchronously from somewhere, right?
Yeah, yeah.
Okay.
And also, let's say, if you have, let's say, real-time connection WebSocket to a server.
Sure, sure.
And get the data from the WebSocket.
Yeah. Actually, one of the things I do is think about the architecture. So this is very prepared for things like that. So in the playground, there is the run function, which gets rerun every time you recompile. So it gives you clean slide. But a lot of applications have those issues. Like you want to load some data and you want to work on a data set that takes a lot of time to load from web or from network or whatever. And for that, there is a function called setup, which actually doesn't get rerun. So what you can do is in your setup function, you can start a network request or a database request, load the data, and then in run function, you just iterate over it. So you don't have to re-download every time you recompile, because that would be a significant time. But you don't want to waste that time, right? So you can use pre-computation there. Very simple. So sockets, you can open sockets and you can interact with that. It's really, I use it for a lot of stuff that uses asynchronous code. I think we have time for one more question. If not, you can just always catch me on the break. Thank you.
Okay, thank you.